Good afternoon, everyone. Welcome back to the Apricot Peering Forum. As you can see, if you've been here before, or even if you are new, the peering personnels happen again at the end of this session. And if you are a network, if you are a content network, if you peer anywhere, or are actually looking at starting to do some peering, then please go to the URL, download the template, and send it to RAF. For the exchanges, you need to send it to Toyama-san. Any and all exchanges who are here, you can use the template and send it to Toyama-san. And the exchanges will be in the last session of the day. Anyway, for this particular session, we have, is this the next slide? What happened? It doesn't move? Whoops. Okay. Okay, this is the agenda for this afternoon. This is what I was looking for earlier. Does that still work, Graph? The QR code? Okay. So we have 3 presentations this afternoon. Walt Volony from Hurricane Electric will do a presentation on how someone can launch a new market launch guide for networks. Then Arnold will do a presentation on PeeringDB. Rather than do just an update, he's going to do a kind of more basic to intermediate introduction to PeeringDB, because we realize that there are a lot of newcomers in the room who might not know about PeeringDB. So, and then we have a presentation by Toyama-san on JPNAP's perspective on peering in Japan. And as I said, we'll do peering personals at the end of the day, or at the end of the session. And please download the template, send it back. The templates look something like this, or this, simple one slide where we need to know what your ASN is and what PeeringDB entry we can go to find all your information. That is pretty much all is needed. So I'll not speak for too long. Walt, you're next.
Press this big button to go forward. Good afternoon. It's my pleasure to be in Kathmandu for the first time ever, so I'm really excited to be here. The agenda for today is we're going to review our data from 2015 to 2018, take a look at Globe local peering, Globe and PLDT local peering, and then we'll talk about when is it time to expand your network or CDN. This is a part 2 talk that I gave back in 2015. So I would recommend highly to look at that talk that's continue online, so you can get a baseline of what we're talking about. That talk dealt with specifically how to do desktop research and in-country research when you're exploring a new market. It's repeatable, scalable. So if you're looking to expand, I would recommend going back and looking at that talk. So first thing, what has changed in the last 3 years? We're going to fly through these slides pretty quickly so that we can save time. So we're going to quickly look at NetFlow, BGP, Renesys, and PeeringDB. My favorite market is the Philippines, because that's where I learned my most, had my most lessons when I was cutting my teeth into diving into new Asian markets. The next few slides will show the changes of NetFlow. And as always, everyone knows when you become local, your traffic will increase significantly. This shows the traffic for PLDT back in 2015, and as you can see, it's roughly 3 gigs. If we flip forward to today, the traffic is peaking close to 10, And this is for traffic that is outside of the Philippines. So you can see that over the last 3 years, it's increased significantly. For Globe, it's roughly 3 gigs. And today it's clipping almost 6. And that's, again, outside of the Philippines. So now we update our chart with traffic from 2015 to 2018. And what we're doing is we're getting a story going, and so that way we continue to develop this chart as time goes by. Some companies that I work for do this every 6 months. Others was every year or two. World report. So this is looking at how many routes are being advertised by both of the companies. Back in 2015, you can see that PLDT had roughly 800 routes, and Globe had roughly, PLDT had roughly 800 routes, and Globe had roughly 234. And today, you can see that their traffic, their graphs, you can see today that their prefixes have grown significantly, as well as their BGP adjacencies. And so now we can go ahead and populate the chart, the graph, and with the rest of the data for 2018 through versus 2015. Route propagation. How are they getting their traffic out to the internet? In 2015, PLDT had 3 upstream providers, and today they added Cogent and Level 3, so now they have 4 upstreams. So they're getting better connected. If you look at Globe, they had KT and Level 3, and today in 2018, they added Cogent. And also, so the next part of this thing is we're going to be looking at how traffic returns to the Philippines. In 2015, you can see that NTT was a major inbound from the world back into the Philippines to PLDT. And today, it's a much more diverse and carriers that are selected. The one thing you can see now is that on the bottom here, you can see that Telia is now more preferred than NTT. If we look at Globe, we can see that this top line represents their peering traffic. So, because they're more, have spent more time peering, and so therefore they're better connected peering-wise. And you can see now still, they have added several other directions back in, but also the darkest line is still their peering traffic. Globe and PLD peering. So back in 2015, when we did this talk for the first time, there was no connectivity between the two networks locally. In June 2016, there was a giant hoopla of that, hey, we now peer locally. But what does the data show? The data shows that traffic from Globe to PLDT, that less than 5%, or check that, less than 0.5% stays local. For Globe, the other direction, less than 1%. Surprising, right? So the data shows that the local peering is less than 2% of the traffic. In other words, all the traffic besides that 2% goes outside of the country. What this means for a CDN and other network is that you have to have 2 nodes, 1 in each location. So is that the right time to go? Do people want to deploy 2 sets of CDN? How do you solve that? Time to expand. The first thing you need to ask yourself is what problem you're trying to solve. Is there actually a problem? Are you okay with the way things are performing now? Do you need to really spend $1 million or more to have 2 different nodes inside of the Philippines? Doesn't make financial sense. We have to look at the cost of long-haul circuits, data center cost, dark fiber and metro, and who owns them. Is there a local import issues or taxation? And what's the local provider peering policy? Do you want to go into a location and pay the local incumbent for peering? Most of us would say no. The last one is there a well-managed IX? In the Philippines, there's PH OpenIX, but I'm not quite sure how well it is run. Does anyone have a presence on that exchange in the room? If anyone wants to get back to me so I can update this deck for the next talk, I'd really appreciate feedback on that exchange. So a typical CDN, when do you expand? Obviously, customer demand is number one. The product requirement, the performance requirement. For the different CDNs I worked for around the world, we need to have the retransmissions less than 1%. Latency needs to be under 50 milliseconds, and legal and contract regulations. Another key factor is network partners, so that you can embed caches deep inside the local provider's network. Here's an example of a typical CDN's performance from outside of the Philippines. We can see that with PLDT, roughly 50% of their traffic has a round trip time of 162 milliseconds. That's less than ideal. And not far behind them is the domestic AS of Globe Telecom, where you see the round trip time is 131 milliseconds. This slide shows the performance and locations being served to the Philippines for PLDT with the different nodes around the world. As there should be no surprise that roughly 70% of the traffic is served from Hong Kong, but the bummer is the retransmits, the retransmits are roughly 4%. That's just wasted resources. What is kind of interesting is that on this slide, one second please, is that the performance from Sydney, there's only just less than a 2% retransmission rate. For Globe, we can see that 77% is being served by Hong Kong, and the retransmit rate is roughly 5%. So for a typical ISP, we have to look at the other things as well. The customer demand, the cost versus potential revenue, the marketing value. What that means is that what other sales will you get by launching a POP? For Hurricane Electric, when we launched Korea, and we saw a giant uptick in sales throughout APAC. For Hurricane Electric, we have a different vision. We do things differently, and we're not pure for profit. Our hope is that we can expand as many of these locations as possibly globally to help wipe out illiteracy globally. We invest all of our profits back into the network so we can continue to expand. Part of those resources we use to build new tools like BGP.HE, the network phone app, and IPv6 training. Here's a list of my resources, and are there any questions? Thank you for listening to me. Have a good day.
Thank you, Walt. No questions, really? Thank you, everyone. Before I ask Arnold, can I ask people on that side of the room to kind of move over a little bit? Back there, guys. That part. Move, move, move. Don't be shy. Move, move, move.
Load balancing.
CK, move some more, not one chair. Move.
How many more do you need in this room?
I want that whole place empty. I think that is better so that it doesn't disturb people walking in front of you anyway. Anyway, so next I have Arnold. I should not remind you, if you are ISP or a content, please send your one slide peering personnel to RAF. We'll be compiling this. And Arnold is going to do an introduction to PeeringDB. Take your time.
Yeah.
Thank you.
Thank you, Gaurav. I will, rather than an update, I will talk a little bit more in detail how to use PeeringDB, to register to PeeringDB, and how to fill in information, basically. So, but first, before talking about how to use PeeringDB, I still want to talk about a little bit about the organization itself. So PeeringDB as a database itself is already around since, I guess, roughly 15 years, and PeeringDB came up as more or less as a project. So Richard Steenbergen thought it might be a good idea to have everything which has to do with peering, and that basically is the information about the networks. This is the information about internet exchanges, and this is the information about facilities or collocation to have in one place, and also to link this information together. So he did it, as said, roughly 15 years ago. He hacked together a database with a graphical user interface, and people really liked it. And over the years, it showed that all the networks, not only the networks, also the IPs, but mostly the networks, if they were looking for peering information, and if they were looking for the information where they could peer with networks, they were relying on PeeringDB. So this led a group of the community to the decision to set PeeringDB on a more sound foundation, and this finally led in late 2015 to the foundation of PeeringDB as a non-profit member-based organization. It's an association, and as said, it facilitates the exchange of user-maintained interconnection-related information, and this is the second paradigm. All the information which is in PeeringDB basically come from the participants which are using PeeringDB. That means a network puts in the information it would like to see there, an IXP puts the information in which it would like to see there, and also the collocation do. And this is also most important, is every participants decide whether or which information he would like to see in PeeringDB. If, for example, a net decided not to be listed at an exchange point, although it's there, then the information simply is not there. The same is for if the network decides, for whatever reason, not to be listed at some collocation, then the information simply is not there, although the network might be there. And if you have not yet done the first step, if you want to register with PeeringDB, simply go to this URL, peeringdb.com/register, and then you will get an account. For networks, we do a simple authentication and authorization against the WHOIS information or RDAP information we find at the different RIRs. And ideally, you should register with the email address which we might find in the RIR record. So having said that, I already mentioned that since late 2015, we are a volunteer organization, and PeeringDB is also 100% funded by sponsorships. That means you as the user, you don't have to pay for PeeringDB. It's absolutely free to use PeeringDB. You can put in your records over there, and also beside the graphical user interface, PeeringDB also has an API. You may hammer the API with request as much as you need and as you want, and you don't have to pay for it. What we try to do is to build a healthy organization, and the reason for that simply is because we found out that PeeringDB is crucial for the peering world, for the interconnection world, and we have to make sure that this database is not only there for today, but also for tomorrow and the day after tomorrow as well. The membership to PeeringDB is open to anyone, and the rules to be a member is quite simple. You have to have an account, and then you only have to subscribe to the governance mailing list, and that's it. And by that, you already get to say what PeeringDB does. So we have a yearly we have an annual meeting. The next annual meeting, because we are distributed, this meeting is not an online meeting, or is an online meeting on the internet. And the next one is in April, 19th of April at 4 p.m. UTC. Besides the board which governs which directs PeeringDB, the more day-to-day work is done by 3 committees. We first have what we call administrative committee, admin committee, or AC, how we say. This is more or less what is the support department, the provisioning department, and this manages the administration of users, user accounts, and PeeringDB records. Whenever you create a record, being it a net record, facility, or collocation, this will not automatically be created unless it's authenticated or proved by an automatic process that you really are the owner. Otherwise, the admin committee gets a ticket and looks into it and sees whether you qualify especially for internet exchange points or facilities. Then, as PeeringDB has to run on hardware, of course, or has to run on machines, and we run the DB as well as a web server. There is the operations committee, which is a quite young committee. It's now half a year old, and this manages the PeeringDB infrastructure. And then, last but not least, there's the product committee, and that might be, at least for the outside world, as the most important committee, because this deals with all the feature requests. So PeeringDB is not set in stone, but what we want to do is to develop PeeringDB to enhance features, and this is also where we need your input. If you have an idea how, or if you would like to see a feature in PeeringDB, or if you find a bug, there is a GitHub page where you can file an issue. Then the product committee will look in this issue, categorize it, and if you think it's worthwhile to implement, then it will be implemented and put on the roadmap. So this is to give you an idea how PeeringDB developed over the roughly now 2 years since we went from PeeringDB 1.0 to 2.0. So this was a quite re-implementation of the database and also of the graphical user interface. And as you can see, we have a good increase in verified users. In 2016, we only counted from the date when the cutover was, which was then 15th of March 2016. We had an increase by roughly 45%, and for last year, 35%. For member organizations behind it, it's almost the same, 22% in 2016 and 30% last year. For peering networks, which are the ASNs, this is 38% for 16 and 40% for for last year. In interconnection facilities, it's 9% and 24%. The reason for these 9% in 2016, as well as the figures for the internet exchanges, is we already did a lot of cleaning especially for the internet exchanges in 2016, as well as for the interconnection facilities. So that means that's the reason you do not see that much growth for these type of records. So the board sat together last year, and what we did is we talked about the strategic direction for last year and this year. And first of all, of course, is that we have to make sure that PeeringDB provides reliable, secure services to the community. Then the next step is, I already talked about, is also that we take in all the requests via GitHub. That means we maintain, develop, enhance the functionality of PeeringDB services and look out to the users to give input to us. Then the third goal is to educate the community on effective use of PeeringDB, they educate the community on interconnection and evangelize also the use of PeeringDB. Then, as said, is because we are 100% relying financially wise on sponsorship, is to encourage the support of PeeringDB via sponsorship. And what we want to make sure is that we at least have a reserve of 2 years of operational funds for long-term stability for the organization. So we think 2 years is a nice interval. We can look up 2 years ahead that should do to ensure that PeeringDB is there from this year's time in 2020 as well. Then what we also want to do is we are not standalone, and we are not only looking for you, for the users, but also want to strengthen the relationship with operators, peering forums, and other related databases. So besides PeeringDB, which also stores information about IXPs, there are other databases which store information about IXP, for example, IXF does, as well, for example, PCH also does. And for co-location, for example, we meanwhile have a strategic partnership with Inflect, which store information about co-location and facilities, and we try to synchronize their data with our data to make the information more reliable. So, as said, there is the new committee of operations committee. The basic reason behind it was when we migrated from PeeringDB 1.0 to 2.0, we simply took over more or less the hardware. We run PeeringDB on hardware which was supplied by NTT and other organizations, and then we had a glitch in last year, and then we decided that we have to take more care about that, and that was the reason to form this committee. The switch over to PeeringDB, to the new platform, which now is running in the cloud, took part in, I guess it was in January, and since then it's running in the cloud. What we also plan to do is to make the source code behind PeeringDB open source, and the reason for that is because we think, first of all, of course, to give back the information to the community, and also the idea behind is if we make it open source, developers are able to work on it, to enhance on it, to have put their ideas in, and so this will lead to even more use of PeeringDB then. So this was more or less about the organization behind PeeringDB, and now more how to use PeeringDB. On the first slide, I showed how to register with PeeringDB, and this is what you see after you successfully register with PeeringDB. You will get back an email where you will have to confirm your email address, and You also see on the login slide whether this was successful or not. You see you have confirmed your email address, and if you want to register your ASN, you simply type in the ASN information over there, click on Affiliate, and then a support ticket to PeeringDB will generate it. This means a ticket will generate it, will open up a ticket in our ticket system, and when one of the admins will look into it. Typically, this will happen within a few hours. If not, then perhaps what also might already have been happened is that the ASN was already registered with someone else, perhaps already years ago, and then what we did when migrating from 1.0 to 2.0, all the users which were at that time registered with PeeringDB automatically are admins, and then your request sits in a queue where the admin has to look at it. What might happen is that, of course, that the admin already has left because it was years ago. And then if you do not get a response, I would say within 2 days or so, then please feel free to send an additional email to support@peeringdb.com, because then it's most likely that it either got stuck in the affiliation request queue of your admin or something other happens. So if you are not a network but an IXP or a colocation facility, then you probably don't have an ASN. What you then do is you simply type in your organization name, and then the same will happen, that the organization will be created, and after that you will be able to fill in other information. So what I've already said is that when we migrated from 1.0 to 2.0, all the network records were copied into the database. The same happened for facility and exchange records, but with PeeringDB 1.0, there were no users associated with IXPs and facilities. What you still can do is you also can, of course, search PeeringDB whether your organization already has been registered. If you find it, and if it does not yet have an admin, what you will see is request ownership on the upper right-hand side. You simply click on that, and then it will automatically generate a ticket which goes off to the support department. Also with PeeringDB 2.0, unlike PeeringDB 1.0, where you needed an own user for each network, multiple records might be under the single organization. PeeringDB 1.0 did not yet have the concept of an organization. It only had the concept of a network, a facility, and IXPs. And what we now introduced is the concept of an organization, and the organization then holds a record of a network, an IXP, or a facility, which makes sense because, for example, look at Equinix or so, they both have, or they have data centers, they have networks, and they have IXPs. So the main concept is to the organization, and all the users are also associated to an organization, and the organization manages your records then. We, for example, see here links which have all three types of records: facilities, networks, as well as exchanges. And also, one account is able to manage multiple organizations. As said, in PeeringDB 1.0, for every network, because you couldn't manage facilities and IXPs, for every network, you had to have an own account, and you had to switch accounts if you would like to manage different networks. So we got rid of that. With one record, you are able to manage as many organizations as you want to like. Of course, you are still able, if you want to separate it, to have different accounts for each organization. And if you log in, you see in the upper right corner your username, and then you see your existing affiliation. And if you type on the menu beside your username, you are able to choose the organization which you want to maintain that. What we also did with PeeringDB 2.0, because we introduced the concept of an organization, we had to introduce the user management. And with the user management, typically, first of all, you have users, the super users, I would say, the admins, which can do everything, which can change, delete, or add information, and then, or do read and write. And then we have the simple members, which are only able to read information. And with the other tab, with the permissions, what you're then able to do is to give fine-grained control of any record which is below your organization. If your organization is simple and only has a network, for example, it does not make much sense. But for example, if you are a worldwide organization which has a lot of ASNs, then you are able to distribute the permissions to each region, for example. Or if you're an organization which has networks and facilities, then you perhaps have people which take care of the facilities and which have nothing to do with the network or with the IXP, and then you can give fine-grained control, create, update, delete permissions to everyone in your organization. And this is the public information side. Is what you here are able to do is to give visibility of your information. That means all of the contact information you put in for your network is either private. This means it's only able to read by you users. That means to see this information, you have to be logged in, which is, for example, useful for only disclose NOC information to registered users. And then you might, for example, have information like sales, which you want to have public visible. So this is, and unfortunately, this is not quite clear how to do that. Because if you log in and go to your organization, then you see several tabs which see add facilities, add network, add IXP, and so on. And most of the users think this is a real place to indicate whether you are peering at an exchange point or whether you are present at a facility. Unfortunately, it's not. What you have to do is to go or to select the network, and from there you click on Edit, and then you are able to add information about public peering exchange point or private peering exchange point. And to add this information, it's quite easy. You go in the field, for example, if you want to add a public exchange point, you simply go in this field exchange, start to type in the information, for example, Mumbai, and then you get a list of internet exchange points which are selectable. Then you click on Mumbai Internet Exchange, and then you are able to fill in the rest of the information. So this is more or less, as said, PeeringDB relies on sponsorship. These are the sponsorship packages. These are the sponsors, and that's from me. Thank you. Any questions? So as said, if you have not yet registered, don't feel shy, please do. And even if you are not yet peering on only have an ASN, simply register, then you already are there, and people are able to look up information about you.
Thank you, Arnold. Surprisingly, this peering forum has been very quiet. I think people just want this to finish so that they can go and be tourist again. But you can't really go because there is a peering social starts at 7. So if you finish by 6, you can go out for an hour. But to get into the peering social, you need one of these invitations. And the peering social is sponsored by Equinix. So please find your friendly or not so friendly Equinix account rep. I think Raf, Horacio, Gwen, who else is here from Equinix, guys? If you can raise your hand so that people know where to come and ask for this. Yep, get your entrance tickets to the Equinix peering forum. Having said that, next presentation is by Toyama-san. Katsuyashi Toyama. He's going to give his perspectives from JPNAP on peering in Japan.
Oh. Oh yeah. That. Yep. Thank you. Oh, microphone. Okay.
You want to use this?
Oh yeah. And there is pointer. No. Okay. No. Oh, this one. Oh, okay. Oh, so good afternoon, everybody. And everyone is very quiet. And probably my presentation also make you sleep. I try to not to you sleep, make you sleep. Okay, so today I would like to talk about an peering scene in Japan from the JPNAP point of view. So, not on the partial view, but the macro view. Yeah. So please listen to me, okay? So my name is Katsuyashi Toyama. Yeah, again, say it again. Okay. So I am yeah. Okay, skip. So I'm from the JPNAP. And maybe you know that JPNAP is two internet exchanges, Tokyo and Osaka. And recently we hit 1.29 terabits totally. And also in Tokyo, we hit 1 terabit. So just the same as in the HKIX, okay? Yeah, and two internet exchanges are not connected. Okay, but this is not so good. Okay, so this is the traffic graph. Recently, the traffic curve is good. And this is, that data is just old, but maybe the Sunday or Saturday or Sunday, we hit the 1 terabit. Okay, sorry. So, first, I would like to talk about Japan briefly. Japan is a country and internet. And this, as you can see, the Japan is in the 6th position in the Asian Pacific in population, approximately 126 million people. Okay, and internet users are 180, so the 4th position, and the penetration of internet users. So Japan and Korea is also the top 1 or top 2, these kind of things. So the internet in Japan becomes very popular, and almost everyone, and even in the baby, using the internet through the tablet, okay? And the broadband penetration history in Japan. So as you could see, approximately 20 years ago, at the time, still we had a dial-up by the analog and ISDN. Some of you are old people, so you are very familiar with that, okay? And 2001, the ADSL started. And at first, 1 megabit, and 5, 10, 40 megabit. And at the time, competition accelerated ADSL penetration, okay? So, but in 2003, the fiber to the home started. And at first, government planned to compete 3 big carriers to install the fibers to the home. But then, as a result, the NTT and electric company and cable TV companies deployed an FTTH. Okay, and currently subscribers need more speed all the time. All the time, subscribers need more speed. So early 2000s, you know, the P2P file share, and the 2010s, and the video is the main driver of the traffic. And this is the data from the Japanese government. And as you could see, the broadband subscribers almost saturated from 2010. And just a little bit growing. But on the other hand, as you could see, this is a traffic per user, per subscribers, incredibly increasing, still increasing. So this data is just slightly older and 1 year ago data. And this year, 2017, also the same growth rate. A year, 40% to 30% to 40%. Okay, so the traffic per users are still increasing, and the red line is the download side, and yellow line is the upload side. Okay, and this is an mobile subscribers traffic on the number of the subscribers and average traffic, and the bar graph is in the subscriber. Yeah, and green lines and download side. And this unit is different than the last one. This is an, not per user, but an estimated 1 day's traffic, okay? So, of course, the mobile users still would like to use more traffic, okay? And this is an increased ratio of the mobile traffic. So, download traffic, the increasing ratio is in the line. So approximately 2011, at that time, I thought that it was a boom of a smartphone at the time. And so the traffic is very increasing, and also 4G and kind of things. Okay. But recently, after 2011 to 2015, the increase rate is slightly down, but these days, the 2016 to 17, again, that increase ratio is starting to increase gradually, okay? So these days, often mobile subscribers see a lot of video or games, yes, that kind of things, yep. So, and also currently, the fiber to the home has been covered in Japan approximately 99%, but its utilization is quite low, 53.6%. So now the Japanese government is trying to increase the ratio, so more users or more usage are necessary. For example, the IoT or some kind of a mobile station, yeah, kind of thing. Okay, so this is the current traffic situation in Japan. And also, I would like to point it out about the Japanese, the broadband deployment situation. And physical access lines built and owned by NTT, KDDI, and the carriers, by local electric power companies or cable TV, as I mentioned. But an NTT local regional company or local companies are regulated not to provide internet access to the end users. They only provide fibers and connection to the providers. So, in the downside, fiber is provided by NTT, but an internet connection are provided by these kind of ISPs. So, so slightly, we sometimes confuse that point. In that sense, the fiber to the home the share of the NTT is approximately 68%, so still dominant. And also KDDI, or electric power company, approximately 20%. And cable TV company and others has 13%. So this is the physical fibers share, okay? But provider share is slightly different. As I mentioned, provider is slightly different business group is providing. So I roughly grouping with a carrier. So the OCN is provided by NTT Com, and Pulala is another entity group company. These are the entity group, and their share is 28%. And SoftBank Group has 11%. And their name is Yahoo BB. And KDDI Group, recently Big Globe has been merged by the KDDI. And our group has 14%. And Sonat or some others that are independent. Okay, so this is the rough Japanese ISP market. So still a lot of big ISPs are compete with each other, how to get the subscribers. Okay, and peering in Japan. These players have peering at an internet exchange or the private peers. And as you may know, the first commercial ISP was established in 1992. And 1 year later, the first internet exchange in Japan was established, 1993. So the motivation is in almost the same other countries, okay? Early internet in Japan, in that age, of course, the United States is in the hub of the internet. So if ISP would like to connect to the internet, then sometimes we have to buy the lease line and connect it to the United States. So if in some cases, two internet service providers, ISPs, in Japan communicate, but the traffic is going through the Pacific Ocean and going back from the US. So we need a shortcut. So the academic group wide project started to internet exchange with some commercial ISPs. And internet exchange history, this slide shows the internet exchange histories. So at first, academic group operated in internet exchanges, but then the ISP needed stable and reliable commercial level operations. So some companies get together and had established commercial internet exchanges. Okay, so that first one is in JPIX, that was established in 1997. And JPNAV was started in the business in 2001. And also we had two in big cities in Japan, and so another one in Osaka. So academic, the wide project started in Osaka in early stage, but in 2002, the JPNAP started the first Osaka commercial internet exchanges. And currently, all the 4 internet exchanges have both in Tokyo and Osaka. Okay, so this is a major internet exchange, and they are all commercial and neutral, carrier neutral. Okay. Yes, and almost. Oh yeah. Okay. Oh, moving forward. Just a moment. Oh yeah. So the almost content providers or OTTs connected to all IXPs, yeah, and to reach all the Japanese subscribers. And on the small eyeball side, they connected 1 or 2 IXPs. Yeah, so these days, 2 or more IXPs connected eyeballs are increasing, but still not all they do not connect to all the internet exchanges. Okay, so this is the okay. So maybe I don't like to show this slide. This is the comparison. Yeah. So this is a rough figure. So yeah, from the AS number or the traffic, yeah, we have to compare that. So Yeah, the number of the ASN in Tokyo, yeah, if JPIX or BBIX is bigger than JPNAP. And in Osaka, yeah, almost the same as JPX and JPNAP. Yep. And the traffic is this portion, okay? And, oh, as you know, the pairing market in Japan is categorized like this. And left-hand side, we categorize in the restrictive and selective ISPs. And right-hand side, I categorize in the open one. So usually the eyeball ISPs are relatively open, and also content or CDN are relatively open. Of course, and sometimes to distribute their contents, they should be selective. And also, still the transit providers are not so peer, they do not have not much peers in IX or PNI. And also some big eyeballs has no very restrictive or peering policies. And I think this is almost the same other countries. But then once we had a big dispute about between the OTT and eyeballs. That approximately 10 years ago, maybe you remember that free ride by OTT. So in that case, in that age, yeah, at the time, in Japan, the gradually broadband subscribers are saturated. And eyeballs providers competed with each other. But then they are providing they are offering the same, almost the same flat rate. So it is a very tough competition between them. And accordingly, increasing traffic by OTT and more investment necessary. And that is needed much cost. So at the time, some big eyeballs would like to ask for the paid peer to account OTTs. Yeah. So that paid peer was successful or not, I'm not sure about that. Yeah. But such kind of dispute and such kind of contract was negotiated at the time. But recently, we do not have explicitly about the free ride discussion. And OTT and eyeballs appear within each other in the major IXPs, yeah, and maybe equal peering. And also, OTT connect with multiple 100 gig ports these days. And just some eyeballs start to use 100 gig ports these days. So the traffic is still booming. And also the recent topic is in Osaka. Then also, as you could see, the traffic graph in our traffic graph in Osaka, yeah, the traffic or the customer in Osaka is increasing. And one of the reasons is because OTT built their first distribution point in Tokyo, but then after they succeeded, they chose not to expand the Tokyo more, but then build another distribution point in Osaka. Because Japan has a lot of subscribers and geographically expanded. So for the redundancies, sometimes needs the distribution. Yeah. So this isn't our impression, but I would like to see my data about in the JPNAP for a number of the networks in Tokyo and Osaka, and also the capacity. And also categorize our customer, and then region by region or country, or by network type, and makes graphs about this. So this is networks, number of networks per region at JPNAP Tokyo. And the left-hand side is then comparing the real number increasing. And I'm sorry, but then I could note the real number, but increase rate is describing within that red arrow. So 2007, 2012, 2017, so 10 years in between the 5 years. So the first 5 years, the number of network is increasing at Tokyo, and that the increasing ratio is less between the 2012 to 17. And as you can see in the right-hand side, the percentage or share of the network per region and country, you could see that the North America or Europe is increasing constantly. Yeah, so that means that Japanese and internet exchanges, not only for the domestic, but also for the Asian hub. Yeah, now they are becoming, okay? And this is for the Osaka, or the same one. So the first 5 years, 1.36 times increasing, but then later, the last recent 5 years, 1.57 increase of the network. And still you could see there is no ISPs in the Asian Pacific region. So still Asian ISPs are headed to Tokyo, not yet in Osaka. Okay. And this is from the network type in Tokyo. So the orange one is an eyeball, so the share of the eyeball decreasing. And also the content type of the customer is increasing. And as you can see, the transit provider is decreasing. So this shows that ISPs gradually relying not on the transit provider, but on peers. So, and this is also the Osaka, almost the same. Yeah. And this is in a capacity point of view. So we calculated the size of the pipe and accumulated. And in the Tokyo, so first 5 years, 2.8 times increasing, but the recent 5 years, approximately 5% increasing. So the capacity is from North America and the EU, or the customers are increasing. Yeah. And increasing the Asia Pacific network, but then their capacity is not so big, okay, at this point of time. So in the future, it will increase, okay. So this is almost the capacity per region at Osaka. Yeah, so almost the same increasing ratio, okay. And capacity per type, also the eyeball is decreasing and content type is increasing. Okay, and Osaka is almost the same. Yeah. So major finding, and this is the proof of our impression. So increasing ratio of both number of networks and capacity. In Tokyo, the first 30 years, just a little bigger, and Osaka is recently increasing. Okay, and increasing ratio is in content type, and next eyeball, and the transit is decreasing. And it works from APAC increasing in Tokyo, not yet in Osaka. And accordingly, not analyzed and shown by the data, the Japanese eyeballs start to connect both Tokyo and Osaka. So that is a new trend. And this is because the lot of content provider from the outside, they are connected to both Tokyo and Osaka. So for the redundancy, the eyeballs also to connect to Tokyo and Osaka. Okay. So, thank you very much. So, peering IXP in Japan, yeah, well, just reported about the broadband has been in Japan has been penetrated, and I talked about the history. And the second hub in Japan, Osaka, is growing. And I think near future in the Japanese situation, more interconnection between the cloud providers. Yeah, and also the more cable TV companies. Recently acquired AS numbers and connecting to internet exchanges. And in the near future, for the enterprises also using clouds, so enterprise may increase connecting to the internet exchanges. Okay, so thank you very much. Yep. And questions and comments?
Thank you, Toyama-san. I hope I woke you up out there in the back. We have the first question.
Hi, Toyama-san. My name's Tom from Cloudflare. You said that the 3 IXPs in Japan are neutral, with Equinix obviously being the neutral one. Is that statement really true, given the 3 IXPs are each owned by an ISP, and that ISP won't interconnect on other IXPs?
Oh, interconnect with others?
So the
Yeah.
3 IXPs, the 3 Japanese IXPs, are all owned by a Japanese ISP.
Yeah. Yeah.
Does that make them neutral? Also, because NTT won't connect on the non-NTT internet exchange. So it doesn't sound like they're very neutral.
Oh, I mean the neutral to connecting to the internet exchanges. So no restriction about carriers. So for the JPNAP case, we do not enforce to use NTT's services or IJ services. Yeah, from that sense, we are very quite neutral. Yeah. And of course, you can buy some transit over our facilities. Yeah, from the NTT, or IIJ, yeah. So yeah, that is the one way to connect, yeah. So from the peering point of view, we are very neutral, yeah, I think.
Hello, Toyama-san. This is William from Chief Telecom. I have a question from the government point of view in Japan. Do you think what will happen if Japan government want to build a new IX by the government? What's your opinion about this?
Yeah.
What if?
So long time ago, yeah, government would thought about to make an internet exchanges, but that is not in the big city like in Tokyo and Osaka, but other regional cities. Yeah, and of course some people, not the government, but try to populate internet exchange in the local area, but many ISPs do not connect, or especially the big ISPs do not want to connect. So such an local ISPs does not populate at this point of time. Yeah.
So there are still government IX in the rural area, or they just closed?
Yeah. They do not, they did not establish or build the internet exchanges by themselves, but they promoted or encouraged.
So Japanese government think about it, but never enforce this?
No.
Okay,
no,
just promote the IX.
Yeah.
Okay, thank you.
Sensible government. Actually, I have a question. So this morning when Alan was talking about all the fibers that go from this part of the world to the US, almost all of them go through Japan. But the number of carriers in the Japanese exchanges is far less than what the number of fibers that terminate through Japan or go through Japan is. So why do you think carriers just transit in Tokyo and not really stop and peer at the exchanges there? I have had a lot of discussion with a lot of carriers in APAC who have circuits that go through Tokyo, but they have no interest or incentive in trying to connect to anything in Tokyo. Any insight?
Yeah, you mean that in Asian Pac carriers go directly to US?
US
Yeah.
through Tokyo, but
Not connected to Tokyo. Yeah. I think that happens. Yes, sometimes we encourage the carriers in the APAC to connect to Tokyo, but the main traffic is going to US, so they need a direct connection to US. But these days, some of the Japanese content becomes popular, and some ISPs in the APAC carriers to try to connect, but still the backhaul from the landing station to Tokyo is expensive. So I think that the backhaul more cheaper than the Asian Pac carriers also have incentive to connect to Tokyo. But then we know that their intention or motivation to directly connect it to US. Yeah.
Okay.
But well, maybe such a number of fibers will be sold.
I think you answered the question. The backhaul is too expensive.
Still, yeah, just a little expensive.
Thank you very much.
Yeah.
Thank you. Up next, we have the peering personnels. I think we have 7 more peering personnels. Raf is going to call them out. If you did not get a chance to email Raf, you still have a chance to come here and give us your AS number as long as you have a entry in PeeringDB so that we know how to find you. So feel free to line up after the 7 have talked to come and tell us what your AS number is and where to find you on PeeringDB. And we have a little bit of time, so Raf.
All right, we have hello. We have a few more peering personals. We have WebWorks, which are Chief Telecom, Yahoo BB, CAT, PCH, and Cloudflare. Please, if you would have your representatives lined up. First up, we have WebWorks.
Hello everyone, this is Saurabh from WebWorks India Data Center, India's most connected data center. As of now, we are operating 3 data centers in India, and we are also very soon coming up with a new data center in Delhi. Our ASN is 33480. Our traffic profile is data center and content. Our peering location in Mumbai is Nixie, Mumbai IX, Tata. We follow open peering policies. You can reach me and my colleague Gaurav at the coordinates mentioned there. Thank you.
Thank you. Hi, good afternoon, everyone. This is William Liu from Chief Telecom. Our ASN is 17408, and our traffic profile is balanced. We have both, a lot of contents in our network and a lot of eyeballs, and our traffic volume is around 100 gig. Our peering policy, of course, is open, and we are available at our own IX, TPX, and of course, Equinix Hong Kong IX, M6 Hong Kong. Oh, did I? Okay. And our PeeringDB entry there are two belongs to our network. Another one is Chief, and one is Chief Telecom Inc. Okay, and you can contact us through peering@chief.com.tw, or me and Julius. We are both here. Thank you very much.
Hello, I'm Shotaro Tadano from SoftBank. I'm in charge of SoftBank peering coordinator from this year. Our AS number is 17676, and our traffic volume is over 4 Tbps. SoftBank is Japanese mobile carrier. We are preparing for new POP in Japan at Tokyo, April 2018. We will install 2 nodes and 10 gigabit Ether and 100 gigabit Ether interface is available. Please contact us if you are interested. Thank you.
Good afternoon, everyone. I'm Bell from CAT Telecom Thailand, or known as CAT Telecom. Our AS number is 4651, and traffic volume around 500 gig. And peering policy is open. We have peering location in Asia, Europe, and America, such as Equinix SG, BBIX, SG, BBX, Hong Kong IX, JPNAP, and Equinix Paris and Equinix San Jose. For more information, you can access our PeeringDB. If you would like to peer with us, please send email to peering@cat.net.th or contact me. Thank you.
Good afternoon, everyone. I am Divya from PCS AS42 AS3856. So we are basically a DNS Anycast service providers and also operators of the route collectors at several exchanges. We are present at 168 exchanges worldwide. And if you'd like to peer with us, you can send us an email at peering@pcs.net or contact few of our colleagues here during the conference and set up the peering. Okay, so we are as42.peeringdb.com and as3856.peeringdb.com. And yes, we did quite a bit of work in Africa, and this year we are planning some in Asia. Thank you.
Hi everyone, my name's Tom from Cloudflare. I wanted to announce that we've actually launched a point of presence here in Kathmandu. It was live as of the end of last week, so if you're visiting any resource on Cloudflare, from this network, you're about 1 millisecond away from our node. Our AS is 13335. We've got an open peering policy. Have a look at PeeringDB for where we are. I'm not going to list it because there's more than 160 locations. You can reach us at peering@cloudflare.com or look for myself or Martin here. Thank you.
Thank you.
Good afternoon, everyone. We tried to send a PPT to him, but couldn't reach. So we are from Power Grid Corporation of India Limited. We are a pan-India power transmission company with OPGW running on high voltage towers, transmission towers. So we provide NLD, and we plunge into Nepal, Bhutan, and Bangladesh as well. Our AS number is 132215. And we are present at almost all the major data centers in India. Okay, thank you. 132215.
132215, that's the AS number. We'll add this presentation to the online archives. Anyone else?
Hi, Richard Lotz with Oracle, and I'm going to hand it to Katie Westlake and give us the AS.
Hi, I'm Katie Westlake, also with Oracle. Our AS is 31898, and we've got our PeeringDB page set up with where we currently are. We've got a few sites across North America and Europe, and we are coming to Asia, and we're coming to Asia very soon. So feel free to reach out to either of us. We'll be floating around. Thanks.
Thank you. Okay. Okay, if there's no one else, you can still send your peering IXP personals to Amazon. Send it by email to him. You probably want to send it before the start of the next session and not wait until the very, very last minute, please. You wait almost the whole day to send the presentation. The template is similar. You send email to him. To Amazon, you want to add something?
Okay, so currently I have the internet exchanges. So if you not called, then please contact me again. So first one is AMZIX, BBIX, BKNX, and Chinix, Equinix, ExtremeIX, HKIX, JPNAP, MEGAIX, MMIX, MumbaiIX, and MYIX, LZIX, SGIX, TPIX. These are the Asia's one. And from the other regions, Brazil, IX.BR, DECIX, Interland, and from the Africa, Zinx, Dinx, and Links from London, and Nix, CZ, Nix, SK. That's what I all got. So if you missed, please contact again. Thank you.
Thank you very much. We can break now at 4. We come back here at 4:30 for the last session of the day. I mean, the second last, because you still got drinks later. And you've got the coupon draft to show out. So please get your entrance tickets to the Peering Social. Raf would be happy to give it out to you. Oh, wow. I should have some. So, break time? Thank you.